Hello, and welcome to another Unreal Engine 4 tutorial. In this video, we're going to be taking a look at how to create and use cube maps in Unreal Engine 4. If you're unfamiliar with a cube map, it's essentially if you took a scene capture of every single direction and you wrote that to a texture that you could then display on a cube that has fake three-dimensionality to it. If you look at what I have in the background here, this is the Epic Zen Garden project that you can download for free from the Unreal Engine Marketplace. And I will link that below. This is the actual scene itself. It is rendered in 3 dimensions. You can see all this here. I have a scene capture component that is approximately right about here. And if we go take a look at what that's doing in a cube map that I've rendered, you can see that we're rendering that scene out in real time to an image that is being mapped onto the face of this cube, and it appears to be sunken into the cube and have three-dimensionality to it. So if you move back and forth, things move a little bit. You can see that there's stuff actively happening, little cherry blossom petals falling. And you can see that, the closer you get to it, the more it feels like you're actually just in that environment. So if you look here, other than the really weird fisheye effect you have going on here, it actually almost looks like you're just sitting in a scene. So this is rendering in real time. That's not something that you would typically want to do. You'd probably just want to take an image of something like this to stick onto something else. They do this in AAA games all the time for things like windows, to have interiors that look like there's something there when there isn't, such as in Watch Dogs or Spider-Man or Bioshock Infinite. You just take an image like this of a 3D scene that then looks like it has three-dimensionality to it and appears to move when the camera moves around it. And so that is one of the things that you can do with this. We're not quite going to do that in this tutorial. What I'm going to do is I'm just going to render something onto a cube that you can see through from all angles. But that's just some things that you could theoretically do with this technique. So it looks pretty cool. It's pretty simple to do. I can just back out real quick before we get into things and show you. I basically just have this is how I'm displaying this cube map. So I'm directionally masking, and then I'm telling it using some nodes how to map the cube map texture onto the object. And then basically, other than that, the only thing that's happening is if we go look over here, we stop simulating. There is a scene capture cube right here, and I have that rendering out to this render target here, which is then selected in this material, and that's how it's receiving this in real time. But this is not the project that we're going to be working in. We're going to be working in the project from my Kingdom Hearts 3 video, because it has a nice cube with some effects on it that we're gonna use to make this a neat looking effect. So we'll open up that project. So if you haven't seen the video, I basically made this stained glass texture with some fake depth to it. And essentially what I'm going to do here is I'm going to replace this background texture with just an image of the inside of a cube that has Donald's face replicated on all sides of it. So with that, it'll look substantially different from how it looks now. So let's just jump into how we're going to make that. So the first thing we're going to want to do here is create a new folder. We'll just call this Blueprints. And this will be where I put my actor that I'm going to create. So right click, create a new actor, and we're going to call this BP Cube Mapper. And the reason why I'm doing this way instead of just a one-off is I want to show you how you can use blueprints and scene capture components to make a pipeline that you could then use to create cube maps from whatever scenes you want in your game pretty easily, or from whatever textures you want. So we have this BP Cube Mapper that I just made. We're going to open that up and drag that over here. So the first thing we want to do is we want to add a cube component, and we're going to make that the root. And then I'm going to make this really big. I'm going to make this 20 on all axes for scale. So it's pretty big. And then we're going to add a scene capture component cube. Nope, that's not the one I wanted. Scene capture component cube. Okay, so we got that there. So now this is going to need a texture target. So we'll just put this in materials and textures, and we'll create, right click, go to materials and textures, and create a cube render target. And we'll call this CRT cube mapper. So this is explicitly going to be for this cube mapper that we're using. We're going to open that again, and we're going to select that. So now we have a render target. So now as this thing is capturing, it will write to this render target. So if you look currently, there's nothing in here. But if we go back to the blueprint, drag that out into the world. So there it is. We go back here. Now you can see it is rendering what it sees to this render target. So this is what the cube map would look like all unfurled. However, you'll notice that it's not picking up the cube right now. It's seeing right through it and seeing into the world. Because if you fly in here, you just see straight through it. So we actually need to create a material that's going to be two-sided so that it will not behave that way. So the first thing we're going to do is, we're going to call this m_cubemapper, and we're going to open that up. And we want to make that unlit, and we want to make it two-sided. And all we really want is to put a texture in here that is going to go straight into the emissive. And I'm actually going to drag off the alpha here. I'm going to use my Donald Duck texture. I just want the alpha mask that I had, because that we're going to be seeing through this onto the surface below. And if I don't do the mask and I do the colored portion of it, it's actually going to confuse this effect a little bit. So I'm not going to do it that way. But essentially, so this is what we want here. We got black and white Donald Duck going into the emissive and unlit two-sided. So apply and save. And now in the cube mapper, we want to set that as the texture. So cube mapper. So now we've got that. So that's the texture. And now if we go take a look, you can actually go inside of the cube and you can see Donald Duck on every face. So now if we go to textures, you can see that we have rendered that out to a texture. Now you can actually change the size of the render target. This is changing, I think, the minimum size, which is the vertical size. So you can see we've got 512 by 256. So this is controlling that Y, even though it's a size X for some reason. So if you want to bump this up, you can. Just be aware that the higher you go with this, the size of this texture gets much larger, because you're basically like 2 times the size of a normal, power of 2 texture of that resolution. I'm going to go decently high. I'm going to go 1024 and save. And we should now have, okay. So now we have a slightly nicer looking, a little bit aliased, but not too bad looking image here. And so that's the basis of how to create a blueprint that is going to automatically generate cube maps for you. And the way you can do this, so this is constantly going to update. So if I change this texture, it will change this render target here. If you want to actually render this out to just a texture that will not change, all you have to do is right click on the render target and you go to create static texture, and that just bakes out that texture immediately. And then we can just call this Donald cube map. So now we have that, and that will be set in stone. So if I go back to this and I change to anything else, it really doesn't matter what, and hit apply, you'll see that the cube changes, the render target changes, but that static texture stays the same. So that is precisely what we want. So now what we're going to do is we're going to use this cube map to render onto this cube. So we are going to go to materials and we're going to duplicate our stained glass and just call this stained glass cubed. And we're going to open that up. So this is kind of a complicated material, not super complicated, but if you want to know what I've done in here, you can go to the Kingdom Hearts 3 video that I made. Basically, I'm just compositing a bunch of effects on here that give it a little bit of 3-dimensionality. The one texture that we really want to mess with is this one here, which is the stuff under the glass in there. We don't want that. We want to change that to something different. Everything else we're going to keep the same. So I'm just going to delete all that. And you can see I was basically just adding this in, or multiplying this in to these black outlines to then create what I had going on. So let me just make this a cube. So now it's just solid colors, but we're going to add in our cube map. So the first thing we need to do is get a texture sample parameter cube. Whoa, why did that open that? Okay, and I don't care what that's called. We're basically just going to find our stuff, go to textures, go to Donald Cubemap, and we're going to drag that into the Cubemap texture here. So you'll notice if you just plug this in, it's going to throw out an error at you because it doesn't want you to do that. You need to tell it what the UVs are going to be, because the UVs for a cube map are a lot more complex than normal UVs. So you get this interior cube map node, and you plug that into the UVs, and that will solve that error, and also it will map things. So you'll notice first thing, it has mapped a bunch of cubes onto this. You can see it's working. However, for whatever reason, this interior cube map defaults to tiling 4x4. We don't want that. We just want it to tile once. So we're going to get a scalar or a vector 2 and make that 1x1. So now you can see we've got a cube mapped onto the inside here. So there are going to be some problems with this, and I'll go back into the main viewport to show that off. This did not, so we got to drag that onto the cube. Okay. So it looks cool, but if you're really paying attention, you'll notice some issues here. So first of all, as you move from side to side, you can tell that these are not lined up correctly, because essentially what you've done is you've taken a three-dimensional screenshot and you're displaying it only from this three-dimensional area, only from one angle. So we basically took the screenshot from what would be looking in, I think, to the positive X here. So you can see positive X is going out that way. And if we look up, you can see that these are lined up correctly. And if we look down, we can see that it's lined up down here as well. I think. Yeah, so that's all lined up correctly. But if we were to go just look at the other side, you can see that Donald is facing the wrong way. And the same is going to happen for every single one of these sides. And the top and the bottom are going to get it the worst because they're completely out of sorts. You can see that everything is messed up there. So we're going to need to tell it which way to look. And unfortunately, you cannot, when you're looking at a cube render target in this, or I can't see that at all. If you're using a cube render target in this, you can drag it, whichever way you want in three-dimensional space, and it'll change what it's taking a picture of. However, if you try and rotate it, it doesn't actually change the orientation of the picture, because it is taking just an omnidirectional image. It's just shooting rays out to render in every direction. So you can't actually change how the image is going to render. Every time, just open the texture so we can have a look at it. Every time you rotate it, it keeps the exact same pattern. It doesn't shift where anything is. It's just the same image. So what you need to do is you need to manipulate the UVs to display the cube map from different perspectives. So there are a couple different ways to do this, and I'm going to go through a couple different ones and just use a merger of all these different ways so that you can see the different ways that you can manipulate these UVs to get a different perspective on your cube map. So the first thing we want to do, we'll just say that we want to fix the x-axis. So everything on the x-axis on both sides looks right. So the way that we're going to do that is we're going to use what is called an inverse transform. So we're going to drag off of these UVs, get an inverse transform matrix, and we're going to get a vec3, and we're going to duplicate that 2 times. because you essentially need to tell it how you're transforming every single portion of every single axis of the matrix. So the first one we're going to want to do is we're going to want to do a -1, I believe. And then a -1 on X or R, a -1 on G, or sorry, on Y or G, and then a 1 on B or Z. So then you plug those in here. And then we're going to need to get another texture sample. And we're going to plug those UVs in. And then what we're going to do is we're going to lerp this between these two situations. So we're going to need an alpha for this. And essentially what I'm going to do here is I'm going to use directional masking, which I've done in a previous video, maybe in a previous couple of videos, but I did it in the portal video if you want to know a little bit more about it. The first thing that we're going to want to do here is we're going to want to get some vec3s, and one of them is going to represent our world normal. So that's going to be 1 on the Z, and then we're going to do a transformation on that. Transform from tangent space to world space. So it's just taking all the tangent normals from the object that has the material on it and converting them to world space. And then we're going to duplicate this, if it'll duplicate. That did not. Okay. And then we're going to take another axis from local space. So if we take a look at what we were thinking about before, we wanted the x-axis. So we're going to go -1, which is essentially looking into the positive direction on the x. And then we're going to take a dot product of these two. So if I just previewed this, you can see what's happening real quick. Is everything that lines up between these two. Essentially, when you're taking a dot product, is when the vectors are facing the same direction. You get 1, which is positive. The closer you get to them being perpendicular to each other, they're 0. And then the further away they're facing from each other, closer to 180 degrees apart, you get -1. So we don't want -1. So what we're going to do is stop previewing this and clamp this. We're going to be clamping this to 0 to 1 so that we can then lerp on that one face. So on the one face, everything is going to be oriented this way, and then on every other face, it's going to be oriented this way. So we'll make sure you plug that into the multiply or into your image so that you're actually doing something here. So let's go take a look at that again. So now you can see it's oriented the correct way. So essentially what this inverse transform matrix is doing is it's flipping each of these angles, because if you put in a 1 for the axis value, it's just going to spit out the same exact image and the same exact orientation. But if you put in a -1, it flips it on that axis. So there we have the x-axis sorted. And now I'm going to show you a different way to tackle this problem for the other axes, just so that you have an idea of the different ways that you can do this. So we're going to move this down, and actually we're going to want to get another lerp here. And we are going to want, so we're going to want to plug this, the second texture that we flipped, into the B of this lerp, and then this lerp into the A of the other lerp. And then we're going to get a multiply here. And essentially, we're just going to multiply this by -1 to flip this directional mass that we have, so that instead of looking for the face that has this texture on it, we're looking for the face that has this texture on it. And then we're going to clamp that as well. And we're going to plug that into the alpha. And so you'll see real quick, this is going between 0 and that number, or 0 and that texture. Everything else will be blacked out. So now we've masked off just those two faces, and those two faces are the only ones that have been done correctly. And we're going to move on to the other ones now. So instead of using this inverse transform matrix again, what we're going to do, and we're going to have to do some aggressive node wrangling here because this gets out of control really quick if you don't pay attention to it. So we're going to grab the interior cubemap UVs, and we're going to rotate. And we're going to do that MF vector 90 node. And this is essentially just rotating 90 around all the axes. And you can pick which way and which axes you want to do. So we're going to copy this texture. And we're going to plug in the counterclockwise Z into the UVs here. So now we've rotated it 90 degrees clockwise, not counterclockwise, but clockwise around the Z axis. And we've got that plugged in here. And now we can plug that into lerp. Or actually, that's going to be on every other axis. So what we want to do is we want to create another lerp here. And this will go into the B. And then this will go in up here. And what we want to do is create another directional mask off of this. So we want to take our world vector again, and we want to duplicate everything we've got here because we're going to do this all over again for another axis. So instead of the x-axis, what we're going to do is the y-axis now, and we want to keep both of these. I believe the first one we want to do is this one. Well, that didn't. I got to plug in the world normals here. So now that should give us another face. And if you look, I've essentially rotated that one correctly already, so that everything fits pretty well. If I didn't rotate this and I just plug this straight in, you'll see that it's going to be off on the top and the bottom. So essentially now I'm just rotating these to correct the sides, because on the sides the image is rotated so that the top and the bottom are always off. And then when we get to the top and the bottom, we'll have to do something a little bit more complex to make sure that that's correct. So now we're going to need one more of these. And instead of clockwise, we want counterclockwise, I believe. And we are going to plug in this other alpha I have here that or this other directional mask that I already made by copy pasting. So now if we look over here, we also have that there. So all of the sides are worked out perfectly. So now you can just kind of rotate around and you can see all the way through, and it looks great. We're going to have to rotate the top and the bottom a little bit more because it's actually looking down the complete wrong axis, and the way that the top and the bottom are mapped on this cube are different than the sides, because you can see the sides all face the same direction, but the top and the bottom don't work that way. So what we're going to need to do here is do a little bit more rotation. We're going to want to mask a little bit more. So we're only going to need one more mask, because essentially we just need to tell the difference between these last two lerps, or these last two faces, not three faces. So what we're going to do is we're going to go down here and duplicate just this portion. That's all we need. That didn't grab that for some reason. Okay, so then we're going to do a dot product. Make sure we grab the world normals, plug those in, and now we've got everything clamped. So essentially we just want to change this from the Y to the Z, and then we're going to plug that into this last alpha, or last lerp, the alpha of this last lerp, which we already plugged into the other lerp that we were using before. And this is getting super messy, so I'm gonna clean this up just a little bit so it's not so awful. Oh boy, I didn't grab that. did it again. Okay, so we've dragged that out a little bit, so we have a little bit of room to work with here because we are going to do just a little bit more. We're going to drag these down as well. Okay, so we want to copy this 4 times because we're actually going to do 2 rotations on each of these faces. And they're going to be in opposite directions because of the way the top and the bottom wind up being lined up. You need to do multiple rotations in the opposite directions on them. So we're going to duplicate our textures and we're going to plug in all these UVs. And for I believe this is the top one, we're going to do counterclockwise on the Y, and then we're going to do clockwise on the Z. And then for this, which I believe is the bottom one, we'll test that in a minute, but we'll do clockwise on the Y and counterclockwise on the Z. We'll plug that in. And then if I'm correct, this goes in the B and this goes into A, but we'll see. Yep, so that was right. So now you can see we've got everything, every single side of the cube displaying correctly. So all you need to do is some transforms to rotate it or flip the image, depending on which way you want to do it. Although to do the top and the bottom and the other sides, anything that's not on the x-axis, you can't just flip it. You do need to rotate it. So that's why I did the rotations here. You can do this one by just rotating it 90 degrees twice, and it'll work out just as you would expect it to. However, this is basically the effect that we're going for. We've got a cube, and it has fake depth. You know, you could do this with the translucent 2-sided material. I just thought it was kind of neat to do it with this effect. So you can look at it from any different side. You could use any different texture on here to make this work. So for instance, I could open up my cube mapper texture, and I could give it something that will actually render. That's not actually rendering. Oh, these don't have alpha, or the alpha is the whole. So we'll do it like this. And now this cube should have numbers on it, which should then just render onto the cube map, and then we can go in and change all of these, to the cube mapper render target, if I can find it. There it is. If it will apply. So now you can see we have numbers on the inside. So you could easily use this workflow to create any kind of cube map you want to display on a cube like this, or you could use it, like I said before, for interior textures for windows that you don't want to actually render things on the inside of the windows because the player's never going to go in. It's a pretty versatile technique, and it's super simple to accomplish in Unreal Engine 4 because it's built into the engine. So I hope this was informative, and I hope you got some cool ideas for some cool VFX out of it. I look forward to seeing what you guys can do with this. If you have any questions about anything that I've done here, just put them in the comments below. If you have any suggestions for things you'd like me to tackle, also put those in the comments below. And I hope you have a great day. Thanks for watching.